Hi everyone, in this video we will build together our book management microservice using Spring Boot. I'm assuming that you are not new to Java and that you have some basic knowledge about Maven build tool. We will start by implementing the entities of our domain model. After that, we will code the repositories or repos using Java Persistence API and the services that we will use in our Spring controllers. Finally, we will test our REST API manually using Postman tool and also by implementing a simple integration test. So before we start coding, what exactly is Spring Boot? Spring Boot is an extension or a layer of abstraction on the top of the Spring framework. It is a great framework for developing microservices and REST APIs in Java. The goal of Spring Boot is to create a Spring application with minimum boilerplate code. With his convention over configuration mantra, Spring Boot provides us the assurance that if we follow simple conventions to do something, the configuration code we must write is minimal or none at all. For the complete Spring Boot reference, I recommend you to check out the documentation on the following link. So let's create our Spring Boot project. First of all, let's make sure that Java is installed here. There we go. Anything over Java 8 should be good to go. We can also test this by simply writing Java. We are not going to go over how to install Java because the assumption here is that you already have that installed, so checking it is enough. The next thing, we want to make sure that we have Maven available. So Maven, I have already installed that locally. Now, generally most IDs come with the Maven distribution already available, so you don't need to get your own, but I prefer to get the last version. So I usually go to a Maven, Apache Maven, and I grab the last version. After downloading Maven, we unzip the file on the C local disk, as shown here, and we edit the path environment variable to add the bin directory of Maven. We also add a new system variable called Maven home, which show the directory of Maven on the C local disk. We will be using the Spring Initializer website of Spring to quickly generate our Spring Boot project. First, we open our browser and navigate to start.spring.io. We are going to select a Maven project. The language is Java, and we will use the latest version of Spring Boot. The group will be called com.cwt.bm. CWT stands for Code with Twins and BM stands for Book Management. The artifact will be called Book Management. We will keep that also for name. And the description will put there Book Management Microservice. The package name will remain com.cwt.pm.bookmanagement. And for the packaging, that will be also jar file. And we will use the Java version 11. We have locally installed Java 14. Next, we will choose dependencies that we want to use. So click on Add Dependencies. You're gonna search for Spring Web, and we're gonna choose down in SQL, Spring Data JPA. We're gonna also choose the H2 in-memory database and the driver for PostgreSQL. Finally, we click on the generate button that will generate for us the zip file that we can import in IntelliJ as a Maven project. I will be using IntelliJ IDEA in this tutorial, but feel free to use Eclipse if you don't have IntelliJ. Next, we will unzip the file, the book management file generated by the Spring initializer. After that, we launch IntelliJ and import the project. And here we imported our book management Maven project. Now that we loaded the project in IntelliJ, let's take a look at the structure of a Spring Boot project. We have a directory structure and a Maven POM file, and in the source main Java, there is a com.cwt.pm package, and inside that, a book management application class. So let's look in the POM file. Inside the POM, there is information that we entered at the Spring Initializer website, and also all the dependencies that we selected like DataGPA, Spring Web, H2 driver, and Postgre driver. Spring Boot provides a startup parent. This is a special starter that provides Maven default. Here we can change the Java version if necessary. I will change it to Java 14 because this is the version installed on my local machine. In the POM file, we have a collection of Maven dependencies called starter. So these are Spring Boot starters. Spring Boot starter is just like a collection of Maven dependencies, and these are the compatible version of these dependencies. So for example, we have the Spring Boot starter web. Well, this is really a collection of Spring Web, Spring MVC, Hibernate Validator, and Tomcat and JSON. These starters save the developer from having to list all individual dependencies. And here is also a section for Spring Boot Maven plugin that package the executable jar or var archive. Now let's look at the book management application class. This Java class has a main method and an @Spring Boot application annotation. This is where our microservices start. With this one POM file and this Java class, we can now build and run our project as a Spring Boot application. We simply run it from the command line using mvn spring-boot run. Now let's build the project. In the terminal window, we type mvn install. This will download all the dependencies to an M2 local repository, then compile the Java sources and package them into one jar file. It may take a while to download all the dependencies for the first time into your local M2 repository, so mine is finished, and so let's check it by looking into the target folder. In the target folder we have the jar file generated. Let's launch it in the command line with java-jar. And after a lot of starter messages, we finally know that the application is running when it prints started book management application. Spring Boot includes already an embedded server, so we don't need to install Tomcat or JT for this matter. By default, Spring Boot microservices use port 8080. Let's see if the application accepts the request via the browser. So I am at the browser and I'm gonna hit the application at localhost column 8080. We get this error page. This is okay because we haven't yet added any real code to our project. So we have no controller, no services, no entities. We will do that next. With Ctrl+C, we can stop the application, and this is the beauty of microservices. It's completely self-contained and you don't have to run multiple Tomcat versions to run different microservices. So everything is just simply self-contained. So the first step is to create the entities of our domain model. Primary entities are book, category, and author. Here you can see how the entities relate to each other on this slide. A book can have multiple authors, and belongs to one category, as you can see. I will define then the following classes: book.java, category.java, and author.java. So let's switch to the code. I renamed the main package from com.cwt.pm.bookmanagement to simply com.cwt.bookmanagement. For Java main and also for test main, the same package. I added a new package, entities, and there is the entity classes category, author, and book. As I said before, this tutorial is for developer with previous GPA knowledge. If you do know, you will recognize the @entity annotation, @id annotation, also a relationship annotation like many to one and many to many. To keep this tutorial simple, a category entity will have two attributes, ID and name. Also, the author entity will have two attributes, ID and name. The book will have many attributes like the ID, the title of the book. We will have many to one relationship between book and category. As I said before, many books belong to one category. Therefore, we have this many to one annotation. And there are a many to many relationship between books and authors. That's why we'll have join table or in between table. They're called the book author that will relate both tables, books and authors. And we will have therefore list for author and then a description for the book and the price of the book. After defining the GPA entities, the next step will be to create data services which invoke the entity manager to create, read, update, and delete the entity. We're gonna use instead Spring Data GPA, and these are repositories which eliminate all that boilerplate code and error-prone code. To use Spring Data GPA for a GPA entity, we declare a Java interface class that extends from CRUD repository, where T is the domain type the repository manages, and ID is the type of the entity ID. So for category, we declare the interface category repository that extend the CRUD repository, and we have category and long as an ID. After defining category repository, Spring Data automatically provides the method to create, update, read, and delete categories. We will have also different methods to search categories. For example, find by ID, find all. We can also create a new query method signature like find by name to search category with name. So let's switch to IntelliJ. I added the package repositories. Within we have three interfaces that extend the interface CRUD repository. We have auto repository, book repository, and category repository. Next, we will create services that will inject these repos. Within the new package services, we have three classes: author service, book service, and category service. Let's look at the book service class. In here, we inject the book repository by auto-wiring it to the constructor. We have the method create book, which delegates the saving of the new book or new book to the book repository. We have the method update book with two parameters, ID and book. We use the parameter ID to find a book by ID. If we find the book, then we can save the updated information, or if we don't find the book, we will throw an exception. We have also other methods like find book by title, find all books, and delete book. Here we are also using the ID to find the book. If we find it, then we delete this book. The other service classes such as author service and category service have also CRUD operation or CRUD method Here, for example, we have create author, update author in the author service class. We have also create a category and update category in the category service class. This CRUD operation will be then used from the controllers. You may ask yourself, when do we implement the method of the author repository interface or the repository interfaces in general? So, well, we don't need to, because Spring Data make that already for us. So that's the beauty of Spring Data. The auto repository interface has the find by name simple query method. To create a simple query method, we only need to declare the return type, begin the signature with find by, followed by an entity attribute name. In camel case, we have in this case name, and query parameter with the data type of the entity attribute. That's a string in this case. Spring Data implements the query method under the cover, but we must follow the rule for declaring query method and correctly map the entity properties to the method signature. This simple query method are really a great code saver, because the Spring Data then eliminates the boilerplate querying code. For more detailed explanation, please refer to the Spring Data documentation. Before implementing the controllers, we need to load a collection of predefined categories, authors, and books into the H2 database. H2 database is a fast database written completely in Java, and it's JPA compliant, so we can connect our application to it in the same manner we will connect to any other JPA database like Oracle or PostgreSQL. We will use at first the H2 database. After that, we will switch to PostgreSQL. Our app use the in-memory H2 database at first, therefore we need to load the data each time the application starts. For that, we will use the Spring Boot command line runner interface. The command line interface allows us to execute additional code before the application has fully started. Therefore, it is a good point to add demo data to our database. The command line is located inside our main class, Boot Management Application. Next, we have to inject our repositories into the main class. An auto-write annotation is used to enable the dependency section. After we have injected the repositories classes, we can use the CRUD methods it provides. I already added the code for creating and saving categories, authors, and book. I saved now 2 books into the H2 database. Next, we will define the database connection in the application property file. Here, first we will define the database URL, and also to show the SQL we set that to true. Now we can see the SQL statement in the terminal. Next, we define the database initialization using Spring JPA Hibernate DDL Auto. We set that to create drop, which means that the database is created when the application starts and it's dropped when the application is stopped. Create drop is the default value if you don't define any. The H2 provide a web-based console that can be used to explore database and execute SQL statements. To enable the console, I added the following lines. The first line enable the H2 console, and the second setting define the endpoints that we can use to access the console. So let's run the application to see if the data are loaded and saved in the database. We use Spring Boot run. After a while, we will see the SQL statement here. We can now access the H2 console by navigating to localhost 8080 H2 console. We launch the browser and go to localhost 8080/H2 console. We make sure we use the same URL that we define in application properties. This here. Copy that and paste that here. The default username and default password is empty. As you can see, the tables are now created in the database. Author, book author category. Let's fetch the book data. We have saved 2 books, and that's correct. So now we have loaded the data in the H2 in-memory database. After defining our entities, repos and services, and also loading our test data into the H2 in-memory database, it's time to create our REST API to make web requests. For that, we will use the @RestController annotation. That's a class level annotation that tells the Spring container that this Java class is going to be used for REST-based services. This annotation automatically handles the serialization of data passed into the services as JSON or XML, but by default, the RestController class will serialize returned data into JSON. Let's see how we can implement the create REST endpoint to create a new category. We use the request mapping annotation. We add a path specification of /categories and a method type request.post, indicating that the method will respond to the request with the path/category and restrict request to only HTTP post request. The @request mapping annotation can be used as a class level or method level annotation. It is used to tell Spring container the HTTP endpoint that the services is going to expose to the world. Post mapping is a kind of shortcut to configure a request mapping with the correct HTTP verbs. The advantage here is that the code is more readable. There are many shortcuts or convenience methods such as get mapping, post mapping, put mapping, and delete mapping. Next, we will use the method find categories to find the data. This is handled by Spring Boot via Jackson dependencies. In Spring Web, he performs the marshalling and unmarshalling of objects to JSON automatically. Retrieving and finding a single item works similar to retrieving several of them. We will add another method called find category to manage this for us. This name is a placeholder that indicates how we expect the URL to be parameterized with the category name in every call. The value attribute is used to establish the root of the URL for all endpoints exposed in the controller class. The name portion of the specified path is an URI variable, and its value is passed to the find category method via the name method parameter by annotating it with @path variable. To update an existing category, for example, changing the name of a category, we will use the put mapping annotation. Here, we are also using the path variable to pass the ID and the new name that we will use for this category. Finally, to delete a category, we use the HTTP delete request using @delete mapping. Here, we create a method that accepts a category identifier as a path variable and remove the applicable category from our database. Let's switch to our IDE. I already added a package names controller and added classes author controller, book controller, and category controller. Here we have the book controller class. As I showed you for the category controller, we have the @RestController annotation. We will use the book service class to implement the method for book controller, find books and find book. We will find the book by title, and here we use the @path variable annotation. And as you can see, we use the shortcut version of the request mapping annotation, get mapping, and post mapping to create a new book. Update book, we will use the put mapping shortcut annotation. And finally, we will use the delete mapping annotation to delete a book. Next, we will migrate our data from H2 database to a real SQL database, in this case, PostgreSQL. Now it's time to move to a real database. I will use the PostgreSQL database so that we will not use our application with a temporary database in the production. We'll move the application property to a new file called application test property. I will copy the configuration from this file, from application property to the new file application test properties, so that we can use this in-memory database for test purposes. After that, let's install PostgreSQL in our machine. I will type PostgreSQL, go to the postgresql.org and click on download. If we go to the download tab here under Windows, because we are a Windows machine, download the installer, we'll choose the last version. Now we launch the installer. Just double click on the installer. Just click on next. These are simple configuration. This is the installation directory. Here we can choose the component. I will stick to the default. PM admin is the UI tools to manage the DB. This is an important step. Here we will pick a password for the database super user, which is known Postgres. So the password I'm gonna pick, just for simplicity, I'm gonna choose password. Just make sure you remember whatever password you use for the database. Click next. The default port is 5432. As long as your machine is not using this port for other software, we should be good to go with this port. I stick with the default and I click next. I just keep clicking next and the installation will begin. There you go. The installation is finished and you can close this tab. Now let's launch the PG admin. So here in the browser, notice that saying please enter your master password for PG admin. That's not the password that we set during the installation. That is just a password to connect to the server interface pgadmin4 tool. Here I am gonna pick a personal password and hit OK. So now let's create our local server. Right mouse click, server. I will call it localhost or local server. And here we use the password that we set during the installation. I will type then password, save password, save. If you expand the server, this is our Postgres server. There is no DB here beside the default Postgres DB. So if we wanna create a new database, just right click here and go to create a database. And just type the database name, book, library, and just hit save. Now we have our new DB. If we click on it, we connect to it again. This is just an empty database without any schemas or table yet. We're gonna have to create our table and this schema of this new DB. Let's go ahead and do that. Let's switch to IntelliJ. Here are the application properties to connect to our real database PostgreSQL that we just created. The first thing is the data source URL. Here we set the right database name, book library, also the right ports and the host, localhost in this case. Here is the username, the password. We're still developing here, that's why I will choose true for the show SQL property. For the DDL property, I will set that to create, so to create our schema, and after that I will set that to none. Before we start the application, we have to make sure that our Spring application is able to connect to our database, and it needs a driver for PostgreSQL to connect to it. We added that already as a starter for PostgreSQL. You can check that in the POM file. Here, as you can see, we have already installed the driver. So let's start our application. Okay, now we can check the database. Click here on refresh and we can check the tables. And as you can see, we have now the 4 tables: author, book, author, and category. We see that we have also the data for author and also for book. Refresh and let's check the row. We have the 2 books that we set in our book management here, and we can test our REST API using, for example, Postman that I already installed on my machine. Before doing that, I will set now this property to none, so we cannot load the data when I start the application again. So let's test our REST API using Postman that I already installed on my machine. Here is the Postman desktop app. You can install it, you can Google it, download Postman and install it in your machine. With this tool we can test our REST API using the PostgreSQL database in the background. So before starting our application, make sure to comment this section, because we already done that in the initialization step. In the property, we had this DDL property set to create, and we make sure to initialize our schemas and also the data in our database. We set that to none and comment this section for building our test data. We have now the data in our database, so we can launch the application and let's check, for example, the list of authors. I hit this API using localhost 8080 authors, send, and I get the authors that are saved in our database, in our real database PostgreSQL. Same for books, localhost 8080 books. We should get 2 books in this case, clean code, yeah, and also design pattern. Yeah, we have 2 books saved in our database, and that's correct. Now in the last section we will check, or we will implement a unit test for our application. This unit test will use the H2 in-memory database. So let's do it. Under source test Java, we will have our units and integration tests, and here under resources we will have our application properties that contains the H2 properties used for test. In the application file, under main resources, we have application property file. Here we are using the real database, which is PostgreSQL, but we are now writing integration and unit test, and for that we are using another application properties file, which include the property for the H2 in-memory database, because we don't want to be writing integration test against the real database. That's why we need to separate the application file, which we have here. Before implementing our integration test, I added 2 SQL files, schema.sql and drop.sql. Schema.sql will add the tables category, author, book, and book author into the H2 database, and drop.sql will delete this table from the H2 database. We will need both scripts in our integration test. So let's now create our integration test. I will add a package called repo, and in this package I will add a new Java class. I will call this class book repository int for integration test. We need some annotations to get access to the repos and code of our main class. So let's add context configuration annotation, and as a parameter for this annotation we're gonna specify the classes that will be used here. We will add, of course, the starting point of our application, book management application. Now, telling this integration test where the starting point of our application is will help this test load the application context for Spring. So it bring then all the beans, all the objects that the application needs, and auto-wire everything properly right, just as it would when the application will be running normally on the server. So we want to emulate the same thing for unit or integration tests. For that, we give the starting point of our application. The next thing we need is the Spring Runner. So we add the annotation run with the Spring Runner class. And we need another annotation called data GPA test. This annotation is specific for data repositories. We will be writing an integration test relating to data, so we need access to the data repositories. We're gonna need one more annotation that will be SQL group annotation. I will pass the code here, and I will import classes. In here we specify some of the SQL file that we want to run inside of it. We need this curly braces, okay? And anytime you need to run some SQL file, you need the annotation SQL at SQL. Don't worry if that's confusing right now. We will write next the test, and it will make all sense, so bear with me. As an argument for this, we need the execution phase. If we want a particular script to run before a given method, and we want a script to run at the end of that given method, we can specify that in this information here. So we have here, for example, execution phase before test method, and also execution phase after test method. Here we like to run the script schema.sql before the given method runs to build all necessary tables for the application to run properly right. We want to make sure that the schema is run on our H2 in-memory database. To specify the schema script, we put comma and write scripts and this scripts parameter. And you can specify multiple scripts in curly braces. We add the path to the schema SQL class path. For the next script, we have the execution phase after test method, and we have also the parameter scripts. Here is the class path to the drop SQL, so we wanna delete table after each test. After specifying the add SQL group and the scripts that will be run before each test method and after each test method, we're gonna inject the repositories that we will need in our first test method. So let's implement the first test method. We will annotate this method with a test, and we will test the creation of the books in our H2 database. So I will call this test method if new book saved, then success. We will create first of all a category with the name JavaScript. And we will save that using the category repo. Next, I will add two authors and save them using the author repository class. Finally, I will create a new book with the saved category and authors. Let's now test if we have one book in our database. Book repository, find or count. So let's run our test. And that's green, so that's perfect. You can implement the other test method for updating and deleting books. I will leave that to you as exercise. So in this tutorial we have implemented microservice small REST API using Spring Boot with PostgreSQL as a real database and H2 in-memory database for our tests. If you want to learn more about implementing microservices with Spring Boot, I will recommend the following books. The first book is Spring Boot Up and Running by Mark Heckler. And the second book is Learn Microservices with Spring Boot by Moises Macero. If you enjoyed this tutorial, please make sure to like the video and subscribe to our channel. In the description, I will put the link to GitHub to get the most update code. Thanks for watching and I will see you next time. Take care and happy coding.